y'all. So, like I said, 7.1, symmetry. Alrighty. So first of all, there's three types of symmetry we'll look at. The first one is what we call symmetric to the y-axis. And to me, when you think about symmetry, think about cutting your body in half vertically so that both sides are the same. That's what we're sort of talking about on this symmetry. So the first one, to be symmetric to the y-axis, the graph is cut in half by the y-axis. Okay, so the y-axis cuts the graph in half. Also, you can fold the graph over the y-axis and it'll land on itself. Now, here's the thing. Any graph that's symmetric to the y-axis, we call that an even function. Okay, so that would be if a graph is symmetric to the y-axis, it is an even function. Now, what that means is the graphs that give you functions that are symmetric to the y-axis, you'll notice they're called even functions because their exponents are even. Like the x squared graphs made the nice parabola. X to the fourth graphs would do the same thing. They would make parabolas. So some examples of an even function. That is symmetric to the y-axis would be our parabolas that we've been graphing. Okay. Notice the y-axis cuts this graph in half. Also, if I took the right side of this graph and folded it over the y-axis, this right side would land exactly on that left side, okay? So that's what's making this symmetric to the y-axis. All right, y'all. So then second, we're looking at the other axis, which is the x-axis. So this would be symmetric to the x-axis. And it's basically the same as the y-axis, except we're talking about the horizontal line now. So these graphs are cut in half. By the x-axis. So what that means, same thing here. You can fold the graph over the x-axis. So fold the graph over the x-axis. And y'all guess what? And it lands on itself. Okay? So now instead of going side by side over the y, we're talking about coming over the x-axis. So an example of a graph that would be symmetric to my x-axis would be a graph that comes out like that. Okay, notice the x-axis is splitting it in half. Also, if I took the top and I folded it over to x, it would land on the bottom half. Now, these were even functions here. This, when they're symmetric to the x-axis like that, it's not even a function because remember, this would fail the vertical line test. So if they're symmetric to the x-axis, remember, it's not even a function. So the third one will be what we get our odd stuff out of. So the third one would be, when y'all, I've used both lines. I've used the x-axis and the y-axis. So the third type is a little bit different. We call this symmetric to the origin. Now remember, the origin is the center of the graph where they intersect. So here's the thing. If it's symmetric to the origin, turning the graph 180 degrees, and we get the same picture. Or you can say that you're getting the same graph out of it, okay? So turning it 180 degrees means like, if my graph was like this, turning it 180 degrees would be flipping it upside down, okay? Now, I will say this. If it's symmetric to the origin, then it is a odd function. Because graphs that are symmetric to the origin, you'll see later in life, they have odd exponents. So y'all, let me show you one that would be symmetric to our origin here. So when we were doing the x cubed graphs, the x cubed graphs came up, sort of went through the middle, and then went up. So notice this graph I got is going uphill left to right. Now look how this graph looks. Starting here and it's going uphill. Now, I'm going to turn it 180 degrees. And y'all look at my graph. It starts here and it's going uphill to the right. The same exact picture when I turn it upside down, okay? So that makes this symmetric to the origin, and it also makes it a odd function. So y'all, we got the three types of symmetry here. So what I'm going to do, I'm going to put this in MathLab and see what y'all do on these problems, okay? So let's go to where your homework would look like. All right, y'all should be seeing my MathLab now. And I'm going to make this graph a little bigger where y'all can see it good. All right, y'all seen the graph?
Yes, sir.
Yes.
All right, so here's the question. Is that graph symmetric to the x-axis, y-axis, origin? Or is it no symmetry?
Is it origin?
Definitely the origin. Y'all look at that picture. It's sort of coming down, going up, coming down. If you turn that picture upside down, this part where the 5 is, where I'm crossing, will be up here. And you'll get the same picture when you flip it upside down. So definitely the origin. Also, I'll tell you how else you can tell. Remember, if it's symmetric to the origin, it's odd. Well, y'all look how many times it's crossing the x-axis. 1, 2, 3. So an odd function will also cross the x-axis an odd number of times. And even functions will cross the x-axis an even number of times. So y'all, you just come and you check your answer. Next question. All righty, so let me make this one a little larger. All right, so on this next graph, y'all, what would you say? X-axis, both the X and Y-axis, Y-axis, or the origin?
Y-axis.
Y-axis, definitely, because that Y-axis is cutting it in half. And if you take the right side, put it over on that left side, it will land on it exactly. So definitely the Y-axis. Good job. This might be one of y'all's best homework assignments all year. All righty. Same question, y'all. Is this graph symmetric to the x-axis? They're asking us first.
Yes.
Yes, because that x-axis cuts it in half, remember? And that top half will fold down onto the bottom. So good job. So you check that one. Then it'll ask us, is it symmetric to the y-axis? All right, y'all, is that? And guess what? That y-axis ain't cutting this graph in half, is it?
No, sir.
It ain't even over near that thing. So we're going to say no on that one. And then, you know, it's probably going to ask us about the origin, I bet. So, is it symmetric to the origin? If we was to turn it 180 degrees, would we have the same picture? Well, y'all, that'd be a no, because if you turn it 180 degrees, the V will be on the right side opening up. It won't look like a greater than no more. It'll look like a less than on the right side, which is not the same picture we started with. So that is definitely a no. And you'll see if it's symmetric to the y-axis or if it's symmetric to the x-axis, there's no way it's going to be symmetric to the origin. There's only one shape I could show you that would be technically symmetric to all of them. And that'd be a circle, wouldn't it? All righty, y'all. So we said no on that one. Now watch the next question. They want to know, let me make this larger. Is this graph right here even, odd, or neither?
Even.
Even, perfect. And there's two ways you can check it. Symmetric to the y-axis, because the y is cutting it in half. And look at that. It touches the x-axis 2 times. So that is even both ways you look at it. All right, let's make this one a little larger. Is this graph, this is pretty much what you might call a sine wave, if y'all have ever seen those. But is it odd, even, or neither?
Neither. It's odd.
Oh, so I got an E, odd, and I got a neither. So check this out. Take that graph and turn it 180 degrees upside down. This part on the left that's going down will end up on the top right, going down like it looks now. So if I was to turn it upside down, it would be the same exact graph. So it's definitely symmetric to the origin, which makes it
Even.
odd.
Oh.
And y'all look at this. How many times is it touching the x-axis? 1, 2, 3, 4, 5, 6, 7, 8, 9. So since it's touching that x-axis 9 times, that's also telling us that this one would definitely be a odd, okay? So are y'all seeing me on the odd on this one?
Yes, sir.
Okay. So y'all, questions on those 5 problems. That's 7-1.
Okay.
You're just going to look at a few graphs and see if where they're symmetric to, okay? Now, this next section is a little bit more work than that was. So we're looking at 7-2. So I'm going to give you some notes, and then we're going to do these ones on MathLab also. So 7-2 is transformations. Now, transformations is how I move a graph from one part to another part of the I'm going to move them around, okay? Now, before we learn the moves, we're going to look at some basic graphs. Because we'll start with these basic graphs and we're going to move them up, down, left, right, and reflect them. And I got like 6 basic graphs we got to know for this section. So y'all, the first one would be our parabolas. And we get the parabolas from the y equals x squared. So that's our first basic graph is the x squared graphs. Next basic graph, and y'all, I got what, 6 of these, I think. The next basic graph is the y equals x. Remember, when you got y equals x, that's a straight line, and it sort of comes right through the center. Now, if you add slopes and you add y-intercepts, then the graph, this will move around, okay? But that's the basic line graph. The third one is my cubes. Y equals x to the third. Well, the cubes, they're the ones that come up, cross through the center, and then head uphill to the right. All right, y'all, let me see. They got a square root of x next. Square root of x. Now, the thing about this one, it's a slow uphill graph going to the right. Remember, square roots, you can't put negative x's in square roots because remember, that makes imaginary numbers. So that's why the square root is only good for your positive x's, okay? All righty. I got a cube root of x. So a cube root, sort of like the square roots to the right, but then it also can go to the left sort of slow. Because remember, you can take a cube root of a negative number and it gives you a negative answer. You take a cube root of a positive number, it'll give you a positive answer. All right, y'all, then there's one more. And this is y equals 1 over x. We call this the reciprocal function because it's the inverse of the x, you're flipping it over. But these graphs right here, on the left side, they sort of come down and head straight down. The right side comes down and goes along the x-axis to the right. Now, we will learn about this later, but y'all see how this graph does not cross over this y-axis? You know why it can't cross that y-axis? Because what happens when I put a 0 into that? It makes it undefined. So a graph can't cross where it's undefined at. And we'll learn later in life, when a graph does this kind of stuff, we call them asymptotes. And we'll learn that like, oh, let's see, test 3 material, I think. So these are the basic graphs they're going to start out with. So what we're going to do, we're going to be moving them around by doing these following transformations. So there's 3 transformations we're going to look at. First, we're going to take these graphs and move them up or move them down. For me to move a graph up or down, that would be a vertical shift. So for a vertical shift, I'm going to have y equals f of x plus or minus b. So f of x would be your function. So if I was doing x squareds, f of x would be x squared plus a number or minus a number. So y'all listen to this. If b is positive, which means I add a number to the end of this function, if that b is positive, the graph will move up b units. Okay? If this b is negative, if b is negative, guess what? That graph is going to go down b units. Okay? So let me do an example of one of these. So let's say, describe how the graph can be obtained by one of the basic graphs. So they're giving me f of x equals x to the third plus 7. So y'all, what you would do on this, we're going to start with the basic graph. Well, y'all, which one of these would be my basic graph? I got an x squared, an x cubed, a square root of x, a cube root of x, or a 1 over x. Well, look here. They're giving me an x to the third in this problem. So that means my basic graph will be the x cubed graph. So I'll start with the basic graph, y equals x to the cube. And then what's it doing to my graph when I add that 7 at the end? Well, y'all, we said right here, if that b is positive, well, that 7 is positive. That means this graph will shift up 7 units. Since that 7 is positive, my graph will shift up 7 units. So y'all with me on that? If that had been a -5, then I'd have started with the x third graph, and I would have shifted it down 5 units, okay? So when you add or subtract to the end of the function is up or down. Now, y'all, the one that gives people the most trouble is this second transformation. It's going to be a horizontal shift. Horizontal, left or right. So that means to get a horizontal shift, you're going to have y equals f of x plus or minus a. Now, I want you to notice the difference. Up here, the number was added after the function. Right here, you're changing the x value of the function. So if the number is inside the parentheses with the x, it's going to move me left or right. So y'all check this out. This part seems sort of backwards. If this a is positive, so if you change the x value by adding to it, it don't move it right. It actually moves it to the left. This is going to move it left a units. So adding inside the parentheses will move me left. If the a is negative, so if I subtract from the x inside the function, that will actually move me right a units. So I'm going to show you an example of that. Let me let y'all catch up a second. But y'all, to me, this is the trickier one. Because when you think about adding to the x's, you think you're going right. But what happens is it changes the value of the x when it's getting evaluated in the function. So that's why it actually moves it the other way that you would think. So let's do an example of that. So we're going to do the same thing. Describe how the graph can be obtained by one of the basic graphs. All righty. On this one, we got f of x equals, now y'all watch the difference here. This is going to be parentheses x plus 3 squared. So notice, I don't have x squared plus 3. I got x plus 3 squared. I'm changing the value of the x before it gets squared, okay? So now I'm going to start with the graph. Of y equals, well, I see an exponent 2 here. So that's telling me I'm going to start with the graph of x squared. Now, since I'm adding 3 inside the parentheses to the x, remember, when I add, that's going to shift my graph left 3 units. Okay. All right, y'all. So now, like I said, if this would have been like an x squared plus 3, then it would be a different situation. But remember, if these numbers are inside those parentheses, you're going left or right, okay? Now the third move is a reflection over the x-axis. Now y'all look here. We're only going to be reflecting over the x-axis. If they give you the option of the y-axis, don't pick it because we're not reflecting nothing over the y-axis in this chapter. That'd be like on the last test when we mess with the y-axis. We're only going to be reflecting over the x-axis. So to get that, type of situation, you're going to have y equals negative f of x. So if I put a negative in front of my function, that's going to turn all those positive y values negative, and it'll turn all the negative y values positive, which is going to make that thing reflect. So an example of this, how about describe how to graph can be obtained by one of the basic graphs. So my function for this one, I'm going to do f of x equals negative x to the third. So my basic graph, I'm going to start with the graph of y equals, well, x cubed is one of my basic graphs. So I'm going to start with x cubed. But guess what that negative's doing? That negative is reflecting my graph. So I'll start with y equals x to the third, then reflect over the x-axis. Okay? So y'all, these are the three moves: vertical, horizontal, and reflections. So what we're going to do, let me pull up MathLab, and I'll show you how to do these problems. You don't really got to plot no points, but you got to know which basic graph you're starting with, okay? So let me go to share that page. So I'll probably have to open it up again. So let me catch up a second. So that was 7-2. All right, y'all should be seeing my 7-2 homework now. Are y'all am I showing a page y equals x minus 9 squared for y'all?
Yes, sir.
Okay. All right, y'all. So there's only 8 of these, and so here's the thing. We know that's going to be the x squared graph because of that exponent 2 there, right? Now they're subtracting 9 inside those parentheses. So we got to know, is that going to move me 9 right, 9 left, 9 down, or 9 up?
9 right.
9 right. So I would go up here to A. Now, so we know it's going 9 right. So what was the graph I'm going to start with? Y equals what?
X to the second.
X to the second. So let me find, y'all got a exponent key down here. And that's what you're going to do on that first one. Now watch this. They want us to graph it. So what's going to happen? I click this, click the enlarge graph box down here. I click that, and it's going to pull this box up. Now, you said we're starting with an x squared graph. Do you see your tools over here? The x squared graph is going to be the U-shaped x squared tool. So what you do is you click that, and then you click the graph. And you can click the graph anywhere you want. It'll put the graph right in the center like a basic graph. Now, you told me this went 9 to the right. So do y'all see this little slide box down here? It's got vertical shift on the left side, horizontal shift on the right side. Don't worry about that shrink stuff on the top. We're looking at the vertical shift, horizontal shift, and then if we got a reflection, we'll click that box in the bottom left. So since this is horizontal, you said I was going to go 9 right. So I got to come down here and grab this little slide control and move it right to 9. But as I move that slide control, y'all look at my graph. It moved right 9 units. Y'all with me? And then you save that and you check that answer. All right, y'all, next one. So look at this one. G of x equals x minus 8. How can that be obtained from a basic graph? Well, is that minus 8 going to make my graph? Well, don't pick shrink. That's not happening. So it's either going to go up 8, down 8, or left 8. Now, I'll give y'all a clue. It's not in parentheses. And right ain't even a choice. So that means that that negative 8
Down.
there you go. It's added to the end of the function. So it's going to go down 8 units. And y'all, this is the straight line. This is what? Y equals X. Okay? That's your straight line graph. And then remember, and really, I'll tell you the truth, on the straight line graph, it's only going to go up or down. It can't be in parentheses. Does that make sense? The line graph will only go up or down when you play with it. Now, this is the only graph you got to find 2 points to graph. Because remember, when you do this one, you got that line tool. And when you use the line tool, you got to find 2 points. So y'all, if I made that x is 0 and put it on my table, when x is 0, y would be 0 minus 8, which is negative 8. So I would plot my first point at 0, negative 8 down here and click that. Now, what if I made my x 8? If I use 8 for an x, that gives me 8 minus 8, which gives me 0. So when x is 8, y is 0. Now remember, the basic graph went right through the center of it. By shifting this down 8, it sort of pulled it down to the right. So this is the only one where you had to plot 2 points, okay? So save it, and it'll make you check that answer. And there's only one doing that. All righty. So this is the 1 over x graph. So what is that minus 2 doing to this graph when it's at the end like that?
Is it horizontal shift?
Oh, I couldn't hear you.
Is it a horizontal shift? I don't know.
Well,
I'm taking a
this one,
guess.
since that x ain't in parentheses with that number, this is like the f of x minus b that we had.
Okay. Okay.
So it's going to go down. So y'all remember, if them x's are not in parentheses and that number's at the end, you're either up or down. So minus goes down. So watch these graphs I'm about to show you. So let me make these just a little bigger, each of them. So which one of them 3 graphs looks like it went down 2 units? A, B, or C? And I'll tell you this, B looks like the basic graph, don't it? B is going right through the origin, sort of. So B is the basic graph.
C.
So either A went down 2 or C. What'd y'all just say?
C.
See, there you go. That's the only one that went down, so you would check that. So that one didn't make you graph it, it gave you pictures. All righty. Oh, we got 2 things happening here. I got a negative, and then an x plus 4 in parentheses being cubed. So, first of all, I'm adding 4 to the x inside the parentheses. What's that plus 4 doing? And y'all, this will be the horizontal. So since that 4 is being added to the x inside the parentheses,
Move to the left.
it's going to go to the left. And then that negative in the front is going to reflect me over the
Right.
x-axis, right? So let's see, which one went left 4 and reflects over the x? Okay, that looks like A, right? Because B went left 4, but they're reflecting it over to y. And remember, we ain't learned how to do the y stuff. So B and C are automatically out. And then D, they tried to go right with it. So it definitely went left. Now remember, I said exponent 3 there. So that means my basic graph is x to the third. Okay, y'all with me? So then we're going to graph that. Now, click the enlarge graph. Alrighty, so that's a cube graph. Remember, that cube is that little squiggly line graph going up the left and right. And that's the second one on the second row, the X cube tool. Click that and click anywhere on that graph. It's going to draw it coming right up through the center. Now we got 2 moves. We did horizontal, we went left 4. So come down and get your horizontal and drag it left 4 units. So that it's at -4. And then on the very bottom, it says reflect over x-axis. Watch my graph when I click that. The graph was going uphill left to right. It's now going downhill left to right. So do your 2 moves in them slide box controls. Save that, and then check your answer. All right, so look at this one. This one wants us to fill it out as we go. So I got x plus 3 squared plus 5. So my first question for y'all, what is the basic graph I'm starting with?
Is it x to the second?
It's x to the second, so I would put in my x and my exponent 2. All right, so you see that 3 inside those parentheses. That 3 is in there with that x. So they want me to figure out what I'm going to do 3 units. Am I going to go left 3 units, down, up, or right?
Left.
Left.
Oh, perfect, left. Good job. And then at the end, it's got the 5. That plus 5, is it down, up, right, or left?
Up.
Up, there you go. Okay, so notice the difference. The 3 inside, left or right. The 5, up or down. So let's see, we had to answer that. Then guess what? We got to graph it. So click the enlarge graph. So that's the x squared graph. So get the U-shaped parabola for the x squared tool. Click anywhere on the graph. It's going to start it in the center. So we went left 3. So that was horizontal. So the horizontal has to come over here to -3. So that moved it 3. And then y'all said, what was the other one? 5 at the end, right? So 5 would be vertical. So I'm going to go to vertical shift and move that to +5. That moved my graph up, and now I can save it. So y'all, the biggest trick on this homework is maybe getting familiar with the math lab. Now I'm going to tell you a trick about this one. This is a square root of x minus 4. Do you see how the x minus 4 is all up under that radical? We would treat it like it was inside parentheses. So treat that -4 like it's attacking the x, and it's not being added on to the end of the function. We're inside the parentheses when we're under that radical, okay? Now it's telling me I'm starting with the square root of x. So what I got to figure out is that -4 taking me down, left, right, or up. Now remember, it's like it's in parentheses, okay?
Right.
Oh, good job. It's going to go right because we're subtracting. And then that'll be 4 units. Okay. All right, let me see my chat. It just lit up. Oh, yeah, I got you, Michelle. I got you. All righty. So now, remember the x squared graph sort of started and went uphill to the right. But which one of these graphs went right 4 units? I'm going to make these bigger. A, B, C, or D. Now remember, the original graph starts in the center of it, in the origin. So which one went up first? A, B, C, or D? And I think I heard it.
A.
A. A went right forward. Looks like B went left, C went down, and D went up. So notice some of these, they're being pretty nice, and they're actually just giving you pictures. All right, y'all, look at this one. A cube root of x plus 2. Notice the plus 2 is not under the radical, so it's not inside those parentheses, okay? It's on the outside. So is that plus 2 going to move this cube root of x down 2 units right, 2 units left, or 2 units up? Now, remember that last problem I done, everything was under the radical. We went left or right. This 2 is on the outside, so y'all need to think vertical. And on a vertical, when we
Up.
2 units.
up 2 units, let's see. So that'd be D. Now we're going to graph it. So let me make these a little bigger, and y'all figure out which one of these went 2 units up. Now we'll say B looks like the actual basic graph, right? It went right to the center. So either A or C went up.
A.
All right, I'm gonna click A. Yeah, that's the only one that went up. Looked like C went down, actually. So check that. Now this one, we don't have to graph. We just got to tell it what we're doing to it. So let's see what they got first. X squared is my basic graph. And then it says shifted blank units. So they're looking at right or left. Well, that -5 is the first thing they're doing. They're sort of doing like order of operations on the inside. So what's that -5 doing to it? Are you going right 5, right 6, left 5, or left 6?
Right 5.
Right 5. Good job. Then reflect it across the X or Y axis. And remember, there's only one I gave you.
X-axis.
X-axis. So then it says shift it blank. So now they're looking at that 6 at the end. Up 6, up 5, down 6, down 5.
Up.
All right, there's my up 6. All right, y'all, let's see what y'all did. Y'all got me a right 5, an x-axis, up 6, And look at that. All right, y'all. So that's all you got to worry about. 7-1, you'll blow through it because it was, like I said, doing the symmetry. These ones ain't too bad once you get used to those two moves, the verticals and the horizontal, okay? The negative in front is always going to be the x-axis. So get used to inside the parentheses, minus is right, adding's left, and then the vertical at the end, plus is up, negatives down, okay? All righty, y'all. So what questions y'all got on that?
I
It's not
have
too-
one question.
Oh, I hear you.
So just how do you, when you have the y equals x and you have to plot 2 points this time,
Uh-huh.
you said there's only one of those, but how did you do that again? I know you
Okay,
plugged
so
in numbers.
let me show you what I did.
Okay.
I was sort of doing it in my head, but I had one, I think it was y equaled x minus, was it 9, I think?
I think so, yes, sir.
Mm-hmm. So on this one, like I said, it was the line tool I chose. And when you choose the line tool, they make you physically graph it. So I was sort of doing this in my head. I said, well, if I let that x be 0, and then I said, well, 0 minus 9 would make this y value, what, -9?
Yes, sir.
And then my other one, I was like, well, what if I made this a 9? And then 9 minus 9 gave me 0.
Okay.
But hey, any points you want. You could have did the 0, 1 like I used to do, and
Yes,
that would
sir.
make that a -9 and what, a -8. Any 2 points will work.
Okay. Okay. Thank you.
And yeah, that was what, like number 2 or 3, I think it was. But yeah, it's the only one that'll, and it should be really similar to this. Probably like an x minus 2, x minus 5, something like that. Y'all, it's not too bad though, is it? You'll probably have more headache out of Math Lab than you will doing the moves. Them little slides, when it opens them little slide boxes, just be careful, they're touchy, okay? Yeah, I got you again. So looks like it keeps knocking you off.